Hello, wonderful people, and welcome back to your last quarter online school. We're going to jump right into it here. Like I said, these videos, I'm going to try and make them as brief as possible, but I do want to talk about a couple things right here off the bat, just because we're getting back from spring break, we're getting our bearings underneath us, and we're getting ready to, kind of venture into a new territory that nobody on earth has ever really experienced before. So kind of cool, kind of scary. But the bottom line is, from here on out, I mean, we have to assume this is the way school is going to be for the rest of the year. And to continue succeeding and to pass this class, you're going to have to continue doing the same thing you were doing when we were in school. You're going to have to put in the effort, okay? You, as students, you guys need to show us that you're ready to make this system work. Okay, I think it's a very fair system for the students. I think it's a very fair system for the teachers, the weekly assignments. But if it doesn't work and we're having students who are not getting the work done and not showing that they're learning the material, yeah, you're going to have to learn on your own. I'm going to be here. I'm going to give you every resource that I can possibly think of that's going to help you and that's going to make you feel like you're right back in that classroom with me and I'm going through these things with you. Like all these videos, that's what it's meant for. It's meant to help you. But you got to understand there's a lot more responsibility on you to get your work done because there's not somebody constantly standing over your desk telling you do this, do that, okay? Maybe your parents are helping you plan things out, but you got to make sure you're getting everything done by that deadline of Friday at 3 p.m., all right? So there's my little pep talk for you. All right, let's make it work as a school. We're one of the best schools in the state. If anybody can make this system work, it's us. But it takes effort. All right, you got to make sure you're reading all the directions every day, checking my agendas, reading Schoology, making sure you know what's going on. And in turn, I'm going to make it as easy as I can for you, okay? This is the setup. I want to talk about the setup of what you're going to be expected to do every week, okay? So basically, every week, we're going to do the same thing we've been doing in class. So I'm going to give you what I'm calling a performance packet every week, all right? And this is what's going to make it simple. Everything is in one file. What I expect you to turn in, it's all one file made up of 3 parts, okay? So as we scroll down here, part 1 is the notes, okay? So this is my theory, and again, trying to keep it simple, okay? There's 3 parts. It's learn it, practice it, apply it. So part 1 will always be you're taking notes, you're learning the material that we're covering. You're learning the new rules, you're learning the new definitions, just like always we've always been doing. Okay? We go down to part 2, practice problems, okay? The rules you just learned, you're going to show me that you can use them. All right? So these are just the basic run-of-the-mill practice problems based on what you learned in the notes. And then the apply section, this is where it can vary a little bit, and I can change things up and throw some different activities at you. But I'm just giving you something so you can see in this performance packet, part 3 for applications is a Scavenger Hunt worksheet. And it's all self-contained here on this one page, so it's kind of nice. So on these videos, like I said, I'm going to give you as much help as I can. We're going to go through all 3 parts. I'm going to try and be brief because one of the beautiful things about a video is that you can pause it and you can go back and you can watch it as many times as you have to. If you miss something, if I'm going too fast, you got control of the video. So imagine how awesome it would be if you could, make me rewind what I said in class and say it again because you were spacing out for a second or something grabbed your attention. Okay, that's a really big benefit. So I want you to use it. All right, use these videos, use my notes that are posted on Schoology. And hopefully between those and the Zoom sessions and the office hours, you can get the help you need to learn this on your own and feel confident about it. All right. So that's my big pep talk. Now that we're all pumped up and excited to get back into it and do some math, let's talk about what we're working on today. All right. So this week we are finishing our notes on the exponent rules. So if you'll remember, I love this little lightsaber laser pointer here. If you remember, we covered in the days leading up to spring break, we covered notes on 5 exponent rules. So it's a good idea right now to do a quick recap of what those rules are, how we use them, and write down a couple examples, okay? That way, on this notes packet, you'll have all the rules in one place. it's a nice reference from here on out. Okay, so, and like I said, I'm going to go through this quickly. I expect if you missed something or if you think I made a mistake, definitely email me. Remember, email is the way we're going to communicate now. All right, so you don't have the luxury anymore of stopping by my desk and say, Mr. Schaub, I'm going to need another day to get that assignment done. Or, I left it at home, I'll bring it in next class. You got to communicate with me via email. If it comes Friday at 3 p.m. and your assignment's not there, you're absent and it's a 0 until you get it turned in, and then you get late credit. But remember, these packets are going to be 30 points each. You get 10 points for the notes, 10 points for the practice problems, 10 points for the application. So all 3 parts are worth 10 points. That's a big grade. You can't take any 0s out of 30. So, all right. Enough talk. Let's get down to it. All right, our first rule, if we can, I'll erase this here. First one we talked about was 0 exponents. I figure let's start with the easy ones and work our way up from there. So 0 exponents, easiest things in the world to work with. Anything raised to the 0 power is equal to 1. All right, so that's and remember, this is a recap. So I'm expecting that we all know this, that you did the problems on it, and you feel comfortable using these 5 rules. All right, couple examples. I do one example with a number base and one example with an exponent base, just so we can see how they interact. Remember, with number bases, you can always simplify it. As it turns out, and we're going to learn a little bit more about this rule, but I gave you a little bit more complicated expression here. But remember, anything raised to the 0 power is 1. So even if there's 2 powers inside the parentheses and they're being raised to 0, that is an expression to the 0 power. It is equal to 1. So it's not 1x, it's not 1xy, it's just the number 1. So all the variables are going to drop out anytime they're raised to the 0 power. Okay, next one. Negative exponents. All right, so with negative exponents, we just have to remember this rule right here. When you have a negative exponent, you move the whole power to the other side of the fraction. So if it starts in the numerator, you move it to the denominator, and you make the exponent positive. So that's how we get rid of negative exponents. This is an important one because you can't leave any answers with negative exponents on them. You got to make them all positive, and this is how we do it. So, and I threw another rule in here because I want you to remember if the power has a negative exponent and it's on the bottom of the fraction, we move that to the top. Okay, so 1 over a to the negative n can be simplified to just a to the n power. Okay, so you move it from the denominator to the numerator, and you make the exponent positive. We could write this as a to the n over 1, but we don't need to write division by 1 ever. It doesn't change anything, so we don't need to write it. Okay, a couple examples. 4 to the negative second. With numeric bases, you always need to get rid of the negative exponent first, and then once you do that, so we move this to the bottom. Get my lightsaber out here. You move the 4 to the second power to the bottom. You make the exponent positive, and now we can simplify 4 squared. You just plug that into your calculator. 4 squared is 16, so our answer here is going to be 1/16. All right, so you can see the relationship between 4 to the negative second, and our answer is 1/16. So it doesn't really look like what you expect it to be, but that's what the answer is. So we gotta get on board with that. All right, and when variables are concerned, let's go here. All right, there we go. So I gave you an example of when you have a power on the bottom. We take that x to the negative third that's on the bottom, we move it to the other side of the fraction to make the exponent positive. And then since we have x to the third power, a variable base, there's nothing else we can do. We don't know what x is, so we just got to kind of leave it like that. That's as much as we can simplify a variable base. Okay, moving right along. Next rule, product rule. Product means, say it with me, multiplication. Thank you. I'm sure all of you said that right along with me. I appreciate it. And so product rule means when we're multiplying 2 powers, we add the exponents. And if you'll remember, I showed you why that works in our previous notes. You should have those. But bottom line, you got to know the rule. When we're multiplying 2 powers that have the same base, it has to be the same base. If this is a to the m and b to the n, there's nothing we can do to simplify it. But if they have the same base, then we can add the exponents. So what do some examples look like for that? Here we have 2 to the third times 2 to the sixth. Since the bases are the same, we can use that rule. We're going to add the exponents. We get 2 to the 9th power, and then when we evaluate that on the calculator, we get 512. All right, numeric base, we can always simplify a power. Variable base, x to the negative third times x to the fifth. They have the same base of x, so we can add the exponents. When we add a negative 3 and a positive 5, we get positive 2. And that works. You don't have to get rid of the negative exponent first. You can just add them together. Just make sure you use the signs correctly. Negative 3 plus 5 is what you type in. It gives you positive 2, so you know the outcome, the exponent is positive 2. All right. Moving on to its opposite, the quotient rule. When we're dividing powers, we do just what you think we would do. We do the opposite of the product rule. Instead of adding the exponents, we subtract the exponents. All right, so you can draw some comparisons there. A to the m divided by a to the n, if the bases are the same, again, then we're just taking, and you got to do this in order because subtraction really matters. Addition doesn't really matter. So we can add these in either order, we get the same answer. These have to go in the right order. The exponent that's on top goes first, the exponent that's on bottom goes second, a to the m minus n. So, fill those in with any number you want. That's how we do it. Let's take a look at some examples. All right, so we get, if you take a look here, 3 to the 9th divided by 3 to the 7th. We don't have to do the math with our calculator and then divide those giant numbers. We can just use the rule. We can subtract the exponents. So 3 to the 9th divided by 3 to the 7th is equal to 3 squared. And of course, since it's a numeric base in this power, we can work that out. 3 squared is 9, so our answer here is 9. With variables, you can use the quotient rule, but you can't really simplify it beyond that. So you'll see what happens here. Sometimes we have more x's down on the bottom than we do on the top. So that should tell us that when the dust settles and we cancel out our common factors on top and bottom, we're going to have some x's left on the bottom. We're not going to have any left on the top. So if you follow the rule, you can see what happens. X to the 4 minus 7. Remember, you have to go in the right order. I've seen dozens of students make mistakes here because they want to subtract it so they get a positive number. But you don't get to do whatever you want in math, unfortunately. We have to do it in order. 4 minus 7 gives us a negative 3. And of course, like I said, if we have x to the negative third, that is not an answer because we have to always write our answers with positive exponents. So we use the negative exponent rule, right? Which means you take that negative power, you move it to the other side of the fraction, and you make the exponent positive. So that's exactly what I did here. Our final answer would be 1 over x to the third. And finally, the power rule. When you're raising a power to a power, you multiply the exponents. So a to the m power to the n power would be equal to a to the m times n. If we look at our two examples here, so inside the parentheses we have 3 to the third power. Could you work that out on the calculator and then square it and get the right answer? Sure. But we can also use the rule. That's why we're learning these, because we want to use them and get used to them. So 3 to the third power to the second power, we multiply the exponents. Remember, don't add them. It's similar to the product rule, but the big difference is product rule, there's 2 different bases. There's 2 different powers. And in the power rule, there's only 1 power. There's only 1 base. So here, 2 bases, here, 1 base. So that's the big way, that's the easy way to tell them apart. So when we do use the rule here, we get 3 to the 6th power. That's equal to 729. We can do that on our calculator. We can get that answer. All right. Here, same thing going on. We're going to use the power rule, and we're going to multiply these exponents. But we get negative 8. So we get x to the negative 8. And, of course, from the last example up here, you know what to do. We can't leave that exponent as a negative, so we got to make it a positive by moving the whole term to the other side of the fraction. All right, again, we're using negative exponents. I am loving this lightsaber pointer. Oh, look, I got 2 of them. Woo! Lightsaber battle. Okay, moving on. All right, so now that we've covered the 5, we've reviewed the 5 rules we've already learned, we're going to learn 2 more today. That's power of a product. So we're kind of combining 2 rules into one, but it's nice to think of it as its own rule. And really, this is very similar to the distributive property. So in my own words, and you can write it in your own words, I always think it's a good idea to define what the rule is so that we can understand it. I mean, obviously, we don't always understand the words they're using, when they define it. So if we have a product inside parentheses and that whole entire product is being raised to a power, here's what we do. All right, let's just erase that. Okay, so you're going to distribute the exponent outside to every base inside, and then you're going to multiply exponents when necessary, okay? So it's kind of like using the distributive property. I'm going to show you what I mean here. But first, let's take a look at why this works. So we'll zoom in over here. Woo! Hopefully I don't make you seasick with this video. I'll try and keep it so it's not moving so much. But remember, these are what's called proofs, and I'm just kind of proving to you why the rule works. Okay, that way you have some background to fall back on. If you ever forget what the rule is, you can expand the powers and you can figure it out for yourself. So let me show you how that works. All right, so on the left side, this is our rule. All right, it's saying when we have two things being multiplied inside parentheses and they're all being raised to the fourth power, like the 5 times 3 to the fourth power, you can distribute that fourth power to each base inside. All right, so, and here's why it works. If you think about 5 times 3 to the fourth power, then if we expand that, that means we're taking 5 times 3, whatever's in the parentheses, and we're multiplying it by itself 4 times. So that's what this looks like. And this side, this is going to be the same the whole way down. So remember, this is a proof. I'm showing you why the left side is equal to the right side. So what you can see here is we have a 5 times 3 times 5 times 3. So we have 8 numbers being multiplied together. And as we know, multiplication is commutative. So it means we can multiply them in any order we want. So what we're going to do is we are going to rearrange the factors. All right, so I have 4 5s and 4 3s being multiplied together here when I expand it. So I'm going to take those and rearrange them and put all the 5s together, put all the 3s together, and then look what we have. We have 4 5s being multiplied together. That can be rewritten as 5 to the fourth, and we have 4 3s being multiplied together. So that can be rewritten as 3 to the fourth. And now you see, with my trusty lightsaber, that the left side and the right side are exactly the same expression. So, ta-da, it works. Let's all celebrate, and let's all go to the practice problems. All right, just this 2 that I'm going to do with you, 2 that I want you to pause the video and do yourself. Remember, honor system, you got to learn this on your own, so you might as well try to do these on your own. Make some mistakes. It's a good thing when you make mistakes because now you're aware of what mistakes you're making. You can get those fixed. And hey, if you're not making any mistakes, then great, you're on the right path. All right, so, but remember, mistakes are our friends. All right, so first one, I would recommend, let's tone this pen down a little bit so I can write on it. I would recommend that you draw the arrows just like you would. So the first thing I want you to understand is, come on, it's a little laggy sometimes. Okay, but hopefully you can see that now. Okay, so I rewrote it over here. And remember, there are 3 bases inside this parenthesis. There's the 2, there's the A, and the B. They all have their own exponent. So when there's not an exponent there, it's a good idea to put a 1 in just as a placeholder, just to remind you what that number is that's there. That way, when you go ahead and distribute that 4, and we're going to multiply all these powers, right? Because it's a power to a power for each base. And then that'll remind you what we're doing. So we're really taking 4 times 1. So this is going to be 2 to the fourth. And then we're taking 4 times a to the third. So we're going to multiply those exponents. 4 times 3 is 12. And then for the b base, 4 times 1 is 4. So we get 2 to the fourth times a to the 12th times b to the fourth. And the only other thing we can simplify here is that numeric base. So our last step is going to look like this. It's going to be 16 because 2 to the fourth power is 16. 16 a to the 12th, b to the fourth. All right? Piece of cake. Not too bad, hopefully. Let's slide on over to number 2. And we got some negatives in here, but we know how to work with those, so just be careful. First thing we're going to do is rewrite it, and I have 1 base in there that doesn't have an exponent, so I'm going to give it an exponent of 1, and I'm going to put that -3 in parentheses because that's really what's happening here. We're raising a -3 to the negative second power. So we want to treat that as a negative 3 when it's inside parentheses. All right, so that's why I rewrote it like this. All right, so when we multiply all 3 of our exponents inside by the exponent outside, okay, we're going to distribute that negative 2. We get negative 3 to the negative 2, x to the negative 4, and y to the negative 8. Again, I'm just multiplying these powers. All right, negative 2 times 4, negative 2 times 2, negative 2 times 1. That's what we get there. Okay, now we take a step back, we look at what we have, and we realize we have a bunch of negative exponents that we got to get rid of. All right, so our next step, we're going to take all those negative exponents that are in the numerator, we're going to move them to the denominator, and we're going to make the exponents positive. Okay, remember, you can't simplify negative 3 to the negative second when there's a negative exponent there. I mean, the calculator will do it for you, but it's a lot easier if you think of it this way. So now that negative 3 is on bottom and has a positive exponent, we can go ahead and square a negative 3. So if you think about it, what do you get when you multiply negative 3 times negative 3? You get positive 9. So watch those signs really carefully here. We don't have anything in the numerator, so we have to put a 1 there. And in the denominator, all 3 of our bases reside there. So we have a 9, we have x to the 4th, and we have y to the 8th. And remember, there's nothing else we can do to simplify that. All right, all the bases are different. You can only combine bases when they're the same. Or you can only combine powers when the bases are the same. All right, so pause the video right here. I'll give you a couple seconds to do that. And I want you to try number 3 and 4 on your own. Go ahead and pause that video, and then once you've done them, start the video up again and see if you got them right. All right, go ahead. I'll give you some pausing music right here. Pause the video. Yeah. All right, you ready? So hopefully you got it right. First one should have got 125 n to the 9th. Okay, because remember, we can simplify that numeric base once we distribute. 5 to the 3rd is 125, and then n to the 3rd, we multiply those exponents. Okay, number 4, you should have got, this is a complicated one, 64 c to the 3rd, d to the 9th over e to the 12th, because when we multiply e to the negative 4 times 3, we're going to get a negative exponent, so we got to move that down to the denominator. Everything else stays in the numerator because we got positive results for the exponents when we multiplied, okay? Remember, that c has an exponent of 1, so when we multiply 1 by 3, we get 3, all right? And then 2 to the second power, that's 4. And then when we raise 4 to the 3rd power, we get 64. So that's where the 64 came from. Or, in other words, if you want to think about it this way, 2 to the 2 times 3 would be 2 to the 6th power, and 2 to the 6th power is 64. So either way you slice it, it works. All right, one more rule to discuss, and we're going to move quickly through this because this is basically the same as the rule we just talked about, but it involves some division. So obviously it's called power of a quotient instead of power of a product. You're starting to see, hopefully, that it pays to know what those words mean. Power, quotient, or not power. Product, quotient, sum, and difference. All right, so quotient means division, so there's going to be some division involved. The good news for us is, let me erase the in other words here so we can write this down. What you're going to do is you're going to distribute the exponent outside to every base in the numerator and every base in the denominator. So it's basically the same thing. We're going to take the exponent that's outside. When we have a quotient inside the parentheses, we're just going to make sure we multiply the exponent outside by every exponent inside. So you want to count up the bases, see how many you have, and make sure you don't forget any. Because the numbers, the numeric bases, they count too. All right, so real quick, let's look at the proof over here. Proofs are always important so we understand where these rules are coming from. If we expand, here's our rule right here, 4/5 to the 3rd power. And if we use the rule, we would get 4 to the 3rd power and 5 to the 3rd power because we're basically just given that exponent of 3 to each base, okay? Well, if we write it out in expanded form, 4/5 to the 3rd power is 4/5 times 4/5 times 4/5. All right. So, and when we multiply fractions, as you can see right here, when we multiply fractions, we multiply straight across numerators and denominators. So what we really have when we multiply that second line to get to the 3rd line is we have in the numerators we have 4 times 4 times 4. So that's where that comes from. And then on the bottom we have 5 times 5 times 5. And if we rewrite these in exponent form, we get 4 to the third on top, 5 to the third on bottom. That's exactly what the rule told us we were going to get. So huzzah, it works. Celebrate. All right, a couple examples. All right, let's take a look here. So in example number 5, we have 2a to the third over b to the fourth, and everything inside that parenthesis is being raised to the second power. So I have 3 bases here that we need to take care of. We have the 2, we have the a, and we have the b. So we're going to multiply all of their exponents by 2. You can see I threw that 1 in there with the 2 to remind myself that I'm multiplying 1 times 2. So we get 2 to the second power, a to the 6th power, 2 times 3, and b to the 8th power, 2 times 4. All right, there's no negatives involved unless there are negatives in the problem, which we'll look at next. You don't make anything negative if you don't have to. We want to avoid those negative exponents. So the only thing we can simplify in the last step is the 2 squared. So that becomes 4. A to the 6th and b to the 8th obviously can't be simplified because they're different. They're powers with different bases. So we can't do anything there. Number 6, a lot of negative exponents in here. But the nice thing is it kind of works itself out because remember, the rule is we're going to multiply the exponent outside by every exponent inside. So what do we get when we multiply -4 and -3? Well, we get a positive 12. So we get x to the positive 12 on top. And then on bottom, we get y to the positive 8, -4 times -2. So it solved our problem for us. We don't even have to worry about negative exponents because we had a bunch here. But when we use the power of a quotient rule, a negative times a negative is a positive. So we're done. It's a one-step problem. Even though it seems complicated, you just follow the rules and you make sure you pay attention to your signs and you can't go wrong. All right, so pause the video and try 7 and 8 and come back to me and see how you did. All right, go. Pause the video. And we're back. All right, I missed y'all. It was a hard time being away from you there. But you know what? We're back together now, and let's see how you did. All right, 7, pretty straightforward. Let me make sure I got the right eraser here. All right. We're going to multiply the exponent on top with the g. We're going to multiply the exponents on bottom for the k, and we get g to the 35th over k to the 15th. Yeah, they're big, goofy exponents. We don't ever expect to see those in real life, but that's how it works. All right. So, and yes, these rules are used all the time in real life, but you usually don't see exponents that big. All right, number 8, you should have gotten c to the 12th over 256 d to the 8th. 256, of course, comes from 4 to the 4th power. So if you do 4 to the 4th power, that's what you're going to get there. All right, so that's it. Those are the 2 new rules that we're adding to the 5 we already had. So you have 7 exponent rules. You got to know them all. So just make sure you're emailing me with questions. I'm going to go on just with the last couple minutes in this video. I know I'm already at a half hour, but you know what? It's important. And I'll get better at this as we go. I'll get a little bit more succinct. But you know what? We've got time. All right. So let's take a look. I did a couple examples for you on my notes just to get you moving in the right direction. Make sure you can check a couple to make sure you're doing it right. All right. So first one. The only thing I want to bring up about this one, let me zoom in on it, is the -3. That is not a -3, even though it looks like it. Okay, remember, parentheses make a big difference here. So what this is saying is it's the opposite of 3 to the -2nd power. So first we have to use the negative exponent rule, and we're going to move this to the bottom. We're going to move this to the top because they both have negative exponents. All right, so when we do that, we get 2 to the 3rd on top, and we get negative, or the opposite of 3 squared on bottom. Okay, so if you think about it like that, instead of saying, because this is not -3, if there would be parentheses around it like that if it were -3 squared. Those parentheses are not there, so what this means is the opposite of 3 squared. So we're going to square 3 first and then apply the negative last. And it's a little counterintuitive. Students don't expect that to be the case, but that's exactly what we need to do. So 2 to the 3rd power on top, that's easy. That's an 8. But on bottom, we get a -9 because we square 3 first. That's a +9. And then we take the opposite of it with that negative sign out in front. All right, so big difference there between a -3 in parentheses being raised to the 2nd power and a -3 with no parentheses being raised to the 2nd power. All right, and then we can rewrite it, but basically I didn't change anything in that last step. I just put the negative sign out front. So I just wanted you to understand that's sometimes how we write the answers there. All right, so that's number 6. Number 14, it looks ugly, but like I said, if you just know which rules to apply and you just apply them one at a time, you can't go wrong, and just follow those rules. So the first thing I notice is that c to the 0 power. That's going to fall out of our problem right away. That's going to reduce to a 1. And of course, we don't have to show a 1 being multiplied by anything else. So that c to the 0 is just going to drop out of our problem. So what we really have, and I simplified the rest of the negative exponents here so you can see what we got. All right, get my laser lightsaber out. So the 2 to the 3rd power, that stays on the top because it's got a positive exponent. I moved a to the negative 3rd to the bottom, made that positive. I moved 8 to the negative 1 up to the top and made that 1 positive. And I moved b to the negative 5 up to the top and made that positive. So knocked out all my negative exponents in the first step. It's a great way to start because who likes working with negatives? Nobody. So, all right, so next step. Now, what else can we do? Well, we have some numeric bases that we can simplify. Remember, nothing really we can do with the b to the 5th and a to the 3rd. They don't have any buddies that have the same bases, so they're pretty much done. They're set where they're going to be. But we do have 2 to the 3rd times 8 to the 1st power, so we can simplify that. 2 to the 3rd power is 8. 8 to the 1st power is also 8. All right, so when we multiply this 8 and this 8, we get 64, and that's as simple as we can make it. 64 b to the 5th over a to the 3rd. All right, and one more example. I really appreciate hanging in there with me. Let's take a look. We got negative 4d in parentheses, all being raised to the 4th power. This is the power of a product rule. So we're going to distribute, and notice both of our bases have an exponent of 1 because it's not shown. So, and in this case, that negative 4 is in parentheses, so we need to treat it as such. I know it's a little confusing, but hang in there. You're going to get the hang of it. Negative 4 raised to the 4th power, we do need to use parentheses in this case. Negative 4 to the 4th power means negative 4 times negative 4 times negative 4 times negative 4. 4 times. That actually ends up getting a positive 256. And then, of course, the d to the 4th power, there's nothing we can do to simplify that, so that's where we end up with number 21. All right, looks a little bit confusing, really not that bad. Okay, just a little bit about this application problem, but I expect you to get this done on your own. I did the first one for you to get started. I'll walk you through the instructions real quick, but this is where you need to apply what you've learned and be able to get this done on your own, okay? And yes, of course, you can always ask me questions. I'm here to help you. Trust me, I am bored. I need something to do. So email me, send me some questions, send me a screenshot of what you're working on. I'd be happy to help you. Especially make sure it's between 10 and 3 because that's when I'm sitting at my computer just waiting for some questions. All right. Anything outside of those times, I'd be happy to get to you as soon as I can. But, you know, we teachers, we have lives too. We have personal lives. So I might be doing something else. I might be out and about and not at my computer. So I'll get to you as soon as I can, but you might have to wait until the next day, you know, when I get back on. Okay, so anyway, the scavenger hunt, here's how it works. You start at this bottom. Let me get my laser pointer out here because it's so much fun. All right, so you start here, and remember, this is in the gray box, that is the answer that you're looking for. That is not the problem that you're simplifying. The problem you're simplifying is right here. This is an easy one to start. X to the 4th to the 2nd power. We multiply those exponents because that's the power rule, and that gives us x to the 8th. So what we're going to do is we're going to look around this worksheet for x to the 8th power at the top of one of the boxes in gray, and it's all the way down here in the corner. So it says if you found x to the 8th as our answer, and we certainly did, then we can go ahead. We know this is going to be our next problem. So you're going to put a 2. So remember how there was a 1 up in the starburst of the very first box. We're going to put a 2 in the starburst down here. We're going to solve this next problem, and we're going to look for our answer somewhere else. All right, and then you're going to put a 3 in that box. And when you're done, you should end up right where you started in that box. Your last answer, let me switch back over here. Your last answer should be y to the 7th power. So if you get to number 12 and you work that out and you get y to the 7th, then you must have done it right. All right, so when I check this, I'm going to be checking your numbers in each starburst, in each purple starburst shape, and making sure those numbers are in the right place. That tells me that you did the assignment correctly. And of course, please show all the work you can. All right, 35-minute video. I promise, guys, I'm going to get better at this. I'm going to stop talking so much, but I really appreciate you putting in the work. You guys have done a fantastic job. Keep it up and keep asking those questions. Keep emailing me until you get it, all right? I want you to feel confident. I want you to take control of your learning. And from here on out for the rest of the year, I'm really not a teacher anymore. I'm a facilitator. You're the teacher now. You got to teach yourself, teach your friends, and get help from me whenever you can, all right? All right, so I will talk to you soon, and good luck with the rest of your online school experience.